I'll walk you through how to access and use Performance Insights dashboard. To access Performance Insights, click on the instances in the top left. What I want to bring your attention to is the column called Current Activity. For those databases that have Performance Insights enabled, this column will show sessions, which is the average number of sessions active in the last 5 minutes. In this case, we have one database with high load. That's the one with the red in the Current Activity column. Red means that the database has some sort of bottleneck or is overloaded. So let's click on this bar and it'll take us to the Performance Insights dashboard. The Performance Insights dashboard is divided into two parts. The top half shows the load on the database over time. The bottom half shows the top SQL ranked by the amount of load that they are putting on the database. And in this case, we can see that some load has spiked up in the last few minutes. In this case, the color of the spike is green. Now, what is green? We can look at the legend to the right and see that green is CPU. So it looks like we're having CPU starvation. And how do I identify a bottleneck? We identify the bottlenecks by looking at the dashed black line called max CPU. That line represents the number of cores on the machine. We can only have as many sessions running on the CPU as there are cores on the machine. If the load goes above the dashed back line, then we know we are waiting for something. Now that could be CPU or that could be some other resource such as locks, IO, commit writes, or others. Now where is that load coming from? We can look at the top SQL on the bottom. In this case, the load saturation is coming from CPU. So we want to find the SQL statements that are consuming CPU. In this case, the only one that looks like it is consuming much CPU is the first line in all green, which is a SQL statement that's running a function called minute rollups. For this instance, we see that it's in CPU starvation. So you could think about moving it to a larger instance size, but that'll probably take time and it'll cost more money. So as a developer, as a DBA, I know now that it's worth my time to spend a day or even a couple of days trying to tune this function, minute rollups, and get the CPU back and be more efficient so we don't have to upgrade the instance size. Now there are a number of options in this interface that we can use. We can explore larger time ranges. By default, we show 1 hour of time. But in the top right, there are other ranges. So I can click, for example, 5 hours and see a longer time range. Now I see some of these green spikes that we just looked at, and there's also some other spike. So what I can do, which is really cool, is click my mouse and drag it across the spike. And here I zoom in onto that bottleneck. Now this bottleneck is something different. It's this light orange color. So if I look into the legend, I can see it's IO XACT sync. Now what is that? Sort of a strange sounding name. If I leave my mouse cursor over the legend entry, it'll pop up help explaining what that wait is. But to summarize what this wait is, it's basically waiting for confirmation of writes to stable storage. So where is this bottleneck coming from? We can go look at the top SQL again and see that it's coming from this insert statement. Now this insert statement says insert into this table authors, some fields and values. It's basically a one row insert. Now by default in Aurora Postgres, we do implicit commits. That means after every insert it does a commit. And so that makes sense. If when we commit, we're waiting for confirmation of writes to stable storage. Well, one way to alleviate or reduce this wait is to, instead of doing one row inserts, we could do multi-row inserts. Now we can look at data by other dimensions as well. So I'm going to go back to the 1 hour view, and if we look at the legend, above the legend it says slice by weights. Now there's a little down caret. If I click on that, it'll pull up some other dimensions. So I have weights, which is the default, SQL, host, and users. So for example, I can select SQL. Now the load is exactly the same, but we see the colors have changed. We're now, instead of grouping by weights, we're grouping by the top SQL. So I can see which SQL we're consuming the most load over time. Now the load in the top SQL is now colored by our grouping on top. Before we saw groups by weights, now it's grouped by SQL. So each SQL maps to itself, so it's just a single color. But I can choose other dimensions on the bottom as well. By default, it's SQL, but I can click on weights or host or users. So let's click on hosts. And this is really interesting. Often we have a set of application servers that connect to a database. And often those set of application servers are to load balance the activity on the database across those application servers. And typically I have the same code installed on those application servers and I'm load balancing, so the profile of the load should be the same. And in this case I can see that the load's quite different on these two servers. The last server is the local host. Since we can't actually get on the box and connect via the box, these represent some sort of internal activity in the database. But on my two servers that I have, I see one's running a single SQL statement, this blue statement, which is, we look at the top, it's that select minute rollups. And the other host is running several different statements. Now, if this is my profile and I expect the same code to be running on both servers, I know something's wrong. So that's a quick overview of the interface. We see how PI makes it easy to see the load on an RDS database, and both to identify when there's a bottleneck and where to act if there is a bottleneck.